Homework from yesterday was to do your construction for finding the perpendicular bisectors of the triangle. So here's an example. So we drew circles A and C, and where those crossed, we put a line down the middle. We did circles B and C, where those crossed, line down the middle, and then circles A and B, and where those crossed, line down the middle. The trick here is you actually want to keep your compass length the same for all three circles, and you only have to draw 3 of them. Okay? The video that I put out there for you guys, in case you needed help with it, I will also include videos today for the 2 constructions, the bisect and copy and angle. But they will also do that. So you can see that the angle bisectors here actually all intersect at one point, which is referred to as the circumcenter. So great job on this one. And the cool thing about the circumcenter, actually, no, yeah, circumcenter. And we'll get into that a little bit later, is that if you were to put your point of your compass on this point, all 3 vertices are actually equidistant. They're the same distance away. It should be from that single point. So you should be able to draw a circle that goes through the 3 vertexes here. Once again, there may be a little error if the compass point didn't go exactly on those points. This is pretty good. So great job if you happen to be the constructor of this one. All right, so that should be your homework answers from yesterday. All right, so once again, we are on homework tonight, page 17, numbers 1 to 5. We are on page 11 in your module book at copy and bisect and angle. All right. So I'll put something down in the chat here. It is Monsters Inc., yes, the background. Welcome to the math factory. Jokes. So for copy and bisect and angle, we just want to look at this open exercise real quick. So you can see that these circles were drawn here, okay? So if I were to take my compass, I can actually check to see, okay, what's special about points D, E, and F. And if you see, I can kind of draw segment CD, and when I go over here, look at it's the same length as DB, okay? Which is kind of neat. And the same thing happens here. DE is actually the same length as AE, and BF, okay, right, is the same length as AF. So what can you tell us about that's special about these points? Does anyone remember the vocab word we talked about yesterday and can help us out here? Any volunteers that might be able to throw out the vocab word from yesterday? George, how are we doing there, George? Remember the vocab word that talked about these points, D, E, and F, in terms of the segment? Where are they on the segment, and what's the vocab word that we could use to define them? How would you describe the location of point E in terms of this segment AC here? So what's the vocab word that means the middle point? Think about it for a second. Needs middle point. If you put the 2 words together, you get, take out the diddle part. Nope, you need the mid and put it together. Very good. You got it. So this is true. So, and there we go. Okay, so points D, E, and F are midpoints since they are the same distance from the vertices of the triangle. So these points on the triangle, A, C, and B, are considered to be vertexes. They're the endpoints for the segments. Okay. And if we draw in, and I want you to do this on your module too, DE, EF, and FD. So if I draw in and connect DE, DF, and EF here, what type of triangle is formed? Abby, what type of triangle is formed there? Very good. Nice. So this is connecting the midpoints. Okay, very good. I'm going to shift down to a little bit smaller so that we can still see this on here. Okay. And what's special about these four triangles that we make here? So we have triangle AEF, CED, right, EFD, and BFD. What are special about those four triangles? Nevaeh, what's special about those four triangles? Nevaeh, are you there? I see your hand up, Nevaeh. Got it. Mm-hmm. Okay. Think about specifically those four triangles themselves. Think about these four triangles, though. What's special about those four triangles? Okay, so they make up the whole triangle. And something else that's kind of neat, right? These triangles, can anyone else think of what it might be? Or Nevaeh, you might know. What's specifically special about these four triangles themselves? Something. Is there anything that looks like this might be the same? Like if I copy this thing right here, and I bring it out, like what do you notice is happening here? Is that like mapped perfectly on top of that? Is it the same exact size? Do you think it's going to be the same for all of these? Right? So what does it mean if this is literally mapping on top of those other triangles? What's that other vocab word we talked about? Anyone can type in here. Feel free to raise your hand and put it in the chat. Oh, someone put it something in the chat. Good. They're the same size, Abby said, which is correct. And besides the same size, right, they're the same shape. And there's a vocab word that means same size, same shape. It starts with a C. Anyone might know what that word is? This is the lovely symbol for it. To an equal sign with a squiggly on top. Congruent, very good, nice job, Andrei, Gianna. Okay. So if you can perfectly map one figure on top of another and everything lines up perfectly, the sides match, the angles match, that means that those two shapes are going to be congruent. They're the same size and same shape. Okay. Awesome job there, guys. All right. And the question is this, thinking about this triangle, ABC, the really big triangle, okay, and the small triangle, CDE, this guy right here, okay, CDE is, is it only going to move one? It's only going to move one. That's okay. Okay. triangle CDE here. What do we know about them? What do we know about this triangle compared to the really big triangle? How do we compare their areas? Anyone see it? How big is this area compared to the whole big triangle? Laura, what do you think? Oh, Nevaeh, making up for, I don't know what you're doing, but you got it right. So this one here, this smaller triangle is 1/4 the size of the bigger one. Or we would say that the of area of triangle ABC triangle ABC is 4 times the area of triangle CDE. Okay? So it's 4 times as big because it takes 4 of these small triangles to make up this big triangle. Okay? So great job there, guys, on that page. Okay? Put a hand up if you are still writing. Need another minute here just to catch up. All right. Okay, so we're going to go over to the next page here. And if you guys would fill in the vocab that's there, I'll make this a little bit bigger so you guys can see it better. This space between the two rays goes with the interior. This is a very wordy definition on down here, so I wanted to make sure that that's the same. All right. Is anyone still writing and filling in notes? Just put a hand up if you need another second here. Okay. Take another minute. Go ahead. Thanks, guys. Just put your hands down as you guys finish, okay? See that our definition of an angle is essentially two rays, okay, that share the same endpoint. So this is a ray that goes from one point and forever in that direction, and there's another ray coming out this way, okay? So this is referred to as an angle. The space that's in between these two rays here is referred to as the interior of the angle, and then the space that's on the outside of the rays could be the exterior of the angle. Now, if I'm referring to this really big angle here, then this space would be the interior, and that would be the exterior. So it just depends on what angle we're referring to. But usually we're talking about the smaller space as the interior, okay? If I were to draw a line or a ray that were to go through the middle here, okay, this would be referred to as an angle bisector. So bi means two and sect means parts, okay? And this part here is going to be congruent to this part down here. So for angles, when we want to mark congruent, we use these little arcs. So we might use two arcs to signify that they're congruent, or one arc, just like we did slashes before, okay? Now, when we name an angle, like angle AOB, the middle letter is always going to be the vertex, okay? So keep that in mind. So here, O would be here, A would be one of the points on the ray, and then B would be the other point on the ray, the other ray. So this would be ray OA, this is ray OB, and this is angle AOB or BOA. I could do the other direction, okay? So the middle letter is always the vertex. And if it's the angle bisector, then these two parts of my angle should be equal, should be congruent, okay? So an angle bisector is defined as a ray, a line, or a segment that divides an angle, and this is usually our angle symbol, into two congruent angles. So instead of writing the word angle, if you want to use the symbol, feel free, okay? All right. Now, in our geometry, this little m that's in front of the word of the angle symbol is referred to as the measure of the angle. That actually means how many degrees is it, okay? So how much turn is there between one ray to get to the other? If there isn't an m, okay, if there isn't an m, then what that means is we're talking about the physical angle that we can see. Just kind of like before when we didn't use the congruent symbol. Oh, that's crazy. All right, just wanted to change those two colors. And apparently I wanted to turn the whole thing blue again. Awesome, there we go. All right, so if the angles are congruent, that means that the physical angle that we can see, okay, are the same. And if we put the m there, that means they have the same numerical measure. So when we're talking about numbers, we use the m. When we're talking about the actual physical angles, we use the congruent symbol with no m. So equal, put an m, congruent, you don't use it, okay? If you put an m and you put congruent, or you don't put the m and put equals, you're not going to lose points or anything. But we just want to make sure we talk about those two things right there, okay? All right. We're going to go to the next page, and we're going to talk about a few things here. So on page 13, okay? So just want to break down some of this wordiness here that goes through, okay? So in this lesson, we move from the working with line segments to working with angles. And specifically, we're going to talk about bisecting and copying angles today, all right? So if you use a protractor, if you guys don't know what a protractor is, okay, looks like this. I don't know where it went on my screen, but it's there somewhere. Apparently not. Let's try that again. Tools, math tools, protractor. There we go. So this is a full protractor. Usually you see the half protractors that look like this. Okay, so here's our protractor for our purposes right now. All right, and you can see that on my protractor, it normally is about 180 degrees. Okay, So my angles that are formed on my protractor always measure 180. All right. And so somewhere between those degrees, all right, of angle AOB, okay, the degree measure is somewhere going to be between 0 and 180 degrees. So 0 degrees means it's a straight, it's just a ray, and 180 means it's a straight line, okay? Now, if C is some point on the interior of angle AOB. So once again, if we draw angle AOB, so A is that right there, O is the vertex, and B is over here. We can put a point C down as long as it's somewhere on the interior. I'm going to try to put it where I think the middle is, okay? If I form an angle by drawing a ray here, okay, we have these two angles, called angle 1 and angle 2, AOC and COB. If I add these two small angles together, what do I get? So if I add this angle right here, okay, and the angle that's down here, what do these two angles have to add to? What do they have to combine to give me? Carrie, what do they have to add together? If I add the red angle and the orange angle together, what angle do I have to get? Well, only if angle AOB is 180, but think about it in the picture here. If I add these two angles together, what angle do they have to create? What angle do they form? If I add this angle and this angle together, what angle do they create? Anybody out there? And what angle do these two angles make? Navia? Perfect. So if I add this top angle, we call it angle 1, with angle 2, I have to get angle AOB back. This is referred to as the angle addition postulate. We'll get into this later, but this is angle addition. Okay? All right. The third thing that's right below that is what's called opposite rays. So opposite rays form a line, okay? They have to share the same vertex. So let's call the vertex O. And if I move in to the left from O in this direction, okay, we'll call this B. Okay, this is ray OB. And if I move in the other direction, and we'll call this OA, you can see that OB and OA form a straight line. Okay, so opposite rays have to share the same endpoint and go in opposite directions, and they form a line. Okay, these two angles, essentially, if we had another line coming off of this, all right, would be considered to be forming 180 degrees, and that can be referred to as a linear pair. So a linear pair is when two angles, okay, form a straight line. So here we have angle 1 and 2, and they add to 180 degrees. So the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. This is a linear pair, okay? Okay. So now that we got through all the vocab, we're going to do some constructions. All right. So put a hand in the air if you still need some time to copy down. Otherwise, we're going to go on to the next page. Okay, go ahead, Zanizifa. All right. So we're going to bisect this angle right here. Okay? Now, if I want to bisect the angle, I'm essentially going to use my construction we did yesterday to bisect a segment. Okay? The only problem we may run into is, where do I put my compass? Where do I put my compass so that I can bisect my angle? Any ideas? Where do we put the compass? Now, what happens a lot is the first answer I get from a lot of people is, well, put it at the end of the arrow. Okay? And the problem that arises here is, what happens if this arrow actually, instead of being there, is like way out here? Okay? What if the arrow is way out here? Toaster. And if I try to put my compass over here now and draw my circles like we did last time, the problem is that it's not going to make, it's not going to find the middle of the angle. Don't do this in your paper, guys. Okay? So when I go more than half and I draw my two circles, the problem I get is that this intersection now is not necessarily in the middle of the angle. Okay? See, when we draw our line here, this isn't going to create the middle of the angle. So we have a problem. We can't just use the end of the arrows. Okay? So what we need to do first is we need to find 2 points that are the same distance away from the vertex. Okay? All right. So step number 1, okay? Step number 1, I'm just going to make this a little bit smaller so that we can see everything here. All right. If I can do 125. That'll work. Okay. So step number 1, we're going to draw a circle around the vertex, and it has to intersect both sides of the angle, or both rays, if you want to say that. Okay. So I can draw any circle I want. The only thing that has to happen is that I have to be able to go through both sides of the angle. So I don't want to make my circle too big where it's not going to intersect this side of the angle, okay? So I want to make sure that when I draw my circle, it crosses through both rays of the angle. Now, both of these line segments here, okay, that we've created are essentially the radii of the circle. So they're both the same length. Guaranteed, these two pieces are the same length, okay? So if this is circle, if we call this A, okay, we drew circle A with any radius so that it intersects twice. Okay, for our purposes of naming, we're going to say step 2 is to label the intersection of circle A, okay, as B and C. And the angle as B and C. And we're going to call this angle A, okay? So now I'm calling this point right here at this intersection B, and this point right here at intersection C. And now all I have to do is bisect that segment that connects the two angles together. So just like we did yesterday when we did the segment bisector, I'm going to do the exact same construction that we did yesterday. Okay? All right. So how did we bisect the segment again? We drew circles B and C with radius more than half. Okay? And then drew a line that through the center of the circles. That's it. Now we can just say it if you want to. Draw circles B and C with radius more than half of BC. And then draw a line through the intersections of circles B and C. Okay? So I'll give you guys time to copy that. And then when you're done, I would like you to go ahead and do the constructions here. So now here's a tip. After you draw your first circle, don't change your compass length. So draw circle A and then just keep your compass the same length and it will always go through the vertex. So you can see when I make my construction here, okay, this circle will always go back through the vertex when you put your compass back down. Okay, so now when I draw my ray or my line, it's going to go from that vertex straight through, and this is guaranteed to be the angle bisector. Now you don't have to draw a line BC here, so if you want to leave that line off of this, okay, you can, just so it looks like this. Okay, so once again, draw, if we want to call this point A, draw a circle around the vertex that cuts through the angle twice, and you don't necessarily need the whole circle. If you want to draw just part of the circle, that's fine. So you just draw the arc that intersects it twice. And then when you move your compass up, we're going to make our football. All right. And then you can see it crosses at the vertex and it crosses in the middle of the angle, those two circles. And then we just go ahead and draw our line out. All right. Does anyone want to try to use the compass on the screen here and do the angle bisector? Does anyone want to take over my screen and use this compass to make the angle bisector? Nobody. Okay. It's all right. Okay, put a hand in the air if you're having trouble doing the angle bisector. Everybody's got it. All right. Okay. Here's what I want you to do next. Turn your page. And we're going to talk about how to copy an angle. Okay, we're going to copy an angle. All right. We're going to call this, once again, we're going to call this A. You know, we're not going to do copy and angle today. So we're going to skip this one for today because we only have about 3 minutes left. All right, so we'll go over this tomorrow. So what I'd like you to do, okay, is for homework tonight, here's what you're going to try to do for tonight. You guys are going to bisect these 4 angles. So 1, 2, 3, and 4. Keep in mind, angle 3, you're actually bisecting the big angle on this side, okay? So not the small, not this part, the part on the outside. And you're going to bisect this line. So just follow your procedures. Draw your circle, okay? From there, you're going to draw your 2 circles above and below, make sure it's more than half, and then bisect it. So do what you would normally do for 3 and 4 here, okay? And I'm going to put a video for you guys to follow to do angle 5. So I want you to try to use the video to do number 5, okay? And then you're going to take a photo, all right, and upload that for the homework. Any questions for me? So homework tonight is on page 17. You guys should be able to do the first 4. For number 4, remember, all you're going to do is do your circle first around the vertex. Okay, so circle around the vertex. Whoa, circle around the vertex. And then once you know where the intersections are, all you have to do is open this more than halfway. And then when you do your 2 half circles or your football here, that line will then go down the middle. Okay, so I'll leave you guys to finish. All right, so when you make your football, your line's going to go down the middle. All right. Tomorrow is asynchronous day, so we'll be doing several constructions. There'll be a video for you guys to watch. Your homework is still due before class starts tomorrow, so make sure you get that uploaded. And I'll be grading your other homeworks as we go along here. So, all right. That is it for today, you wonderful people. Hope you guys have a great day. You guys can start heading off to your next class.